So in the first video class, we should have learned that a rotation clockwise is a negative angle measure, and a rotation counterclockwise is a positive angle measure. And we can measure angles in revolutions, degrees, and radians. And a couple of the main conversions we learned is that 1 radian is approximately, keyword there, approximately 60 degrees. Give you an idea of how to estimate there and mentally do those. And then also that pi radians is exactly 180 degrees. So 3.14 radians is 180. So when we convert from degrees to radians, we can use this proportion. D is to R as 180 is to pi. So if I have 85 degrees, I'm going to put 85 in place of that D. And then to solve for R, I'm going to cross multiply and divide. So R is going to equal 85 pi divided by 180. Which 5 goes into all of those. 5 we could reduce to be 17 pi over 36. And that would be what we call the exact value of radians. If we would just use our calculator and get an estimate there, we could just take 17 times pi and divide by 36. We're going to have about 1.48 radians. 312 degrees, we're going to take 312 divided by R. It's equal to 180 over pi. Cross multiply, so R is going to be 312 pi divided by 180. We could reduce that. Kind of an easy way of reducing, if you just type in 312 divided by 180 on your graphing calculators, you get 1.73 repeating. But then if you just go to math, the first button changes it to a fraction, hit that twice. And so this reduced would be 26 pi over 15. And again, that would be what we call the exact value. The decimal value would be about 5.44 radians. 817 degrees. Hopefully you realize that that's way more than 1 revolution. It's actually more than 2 revolutions. And so we're going to take 817 times pi divided by 180. And that is going to give you 14.26 radians. So realizing that a complete revolution is 6.28 or 2 pi, this is approximately 14.26 radians. If I'm going from radians to degrees, now it is, I'm putting the 2 in for the R, and then to solve for D, I'm going to cross multiply. So I have 2 times 180 divided by pi. So I have 360 divided by pi, which is 114.6 degrees if I'm rounding to the nearest tenth. And I could probably do that in minutes and seconds also. This next one, I'd have D is to negative 5.4 as 180 is to pi. I'm going to cross multiply, so it's negative 5.4 times 180 divided by pi. Which is a negative 309.4 degrees. The negative just meaning rotating clockwise from that initial ray. Then, if I'm giving you the exact value, so 3 pi over 5, the easiest way is just to realize that pi is 180. So I could put 180 in place of pi, and just take 3 times 180 divided by 5. So this would be 108 degrees. And likewise, in this next one, I'm going to take 2 times 180 and divide by 9. And I'm going to get 40 degrees. Coterminal angles. These are angles that are in the exact same position. So if I would start with this initial ray, and I rotate it, let's say 75 degrees. I could find another angle in the same position if I would just keep rotating another 360 degrees. If I did that, I would just add 360. And so one coterminal angle to this would be 435. But I could do that multiple times. Just keep rotating, keep adding 360. So I'd have 435, 795, 1155. And I could also keep subtracting 316 if I rotate in the other clockwise direction. And then I would have a negative 285, a negative 645, and so on. So to get coterminal angles, you simply can just add or subtract 360 as many times as you would like. If this angle is in radians, so for example, if this angle is 2 pi over 3, which hopefully you know, since 180 divided by 3 is 60, 2 times 60, this would be the same as 120 degrees. But if I rotate this and I want the angle to be in radians, I'm rotating a complete revolution, which is 360 degrees, but it is also 2 pi. So I would just keep adding and subtracting 2 pi. Now to do this, you need to have a common denominator. So this 2 pi could be written as 6 pi over 3. And so if I keep adding and subtracting 6 pi over 3, I would get 8 pi over 3, 14 pi over 3, 20 pi over 3. And if I'm subtracting that, I would have negative 4 pi over 3, negative 10 pi over 3, and so on. So that's how you find coterminal angles, which are angles in the same position.